This is section 10.5 of Honors Algebra 2, Laws of Logarithms. So using the laws of exponents, we can derive the laws of logarithms. So let's let b be a positive number where b is not equal to 1, because b is going to be the base of a log, and we know that needs to be positive and not equal to 1. And let's let m and n be positive numbers. Since we know by the laws of exponents that b to the x power times b to the y power equals b to the x plus y power, so the bases are the same and multiplied, and we add the exponents, that would allow us to derive that log base b of m times n equals the log base b of m plus the log base b of n. The actual proof of that is in your book on page 473. Feel free to look at it. But what this is saying is that if I'm multiplying two numbers inside of a log, this is the same as taking the log of each one and adding them together. Log base b of m times n equals the log base b of m plus the log base b of n. Similarly, since when we're dividing two bases, I subtract the exponents, then the log base b of m divided by n, so dividing two things inside of a log, equals the log base b of m minus the log base b of n. So if I'm dividing two things inside of a log, I can take the log of each one and subtract them. Since b to the x to the k power equals b to the kx power, or b to the xk power, so power raised to another power, I multiply the powers, that allows me to take the log base b of m to the k power, so an exponent inside of the log, and pull that out front and multiply it out front as k times the log base b of m. So a power inside of a log becomes a multiple of the log itself. Three very, very powerful properties of logarithms that come directly from the properties of exponents. So these allow us to manipulate and evaluate some logs. So here are a whole bunch of examples. In these first three, we're going to expand each logarithm to write them as the sum or difference or product of different logs and numbers. So number one, the log base 6 of m squared times n cubed. So since I am multiplying inside of the log, I can split it up to take the log of m squared plus the log of n cubed. So the log base 6 of m squared plus the log base 6 of n cubed. When I'm multiplying inside, I can split it up as adding two different logs. Notice the base of the log stays the same. And then I have powers inside of each of those, so I can bring those powers out front to multiply in front of the logs. So that 2 comes out front as 2 times the log base 6 of m, plus that 3 comes out front of that log, 3 times log base 6 of n. So now I've expanded that log out as far as I can go. That way, if I knew what the log base 6 of m was and knew what the log base 6 of n was, I could evaluate that. Number 2, the log base 2 of the square root of m over n to the 5th. First thing I need to do is take care of that square root, and I remember that a square root is really a 1/2 power. So this is m over n to the 5th, all raised to the 1/2 power, and the log base 2 of that. And I can bring that power out front, that 1/2, and multiply it by the log base 2 of m over n to the 5th. Now I'm dividing inside of that log, so dividing inside of a log, remember, means I can split it up as subtracting two logs. This is 1/2 times the quantity of log base 2 of m minus log base 2 of n to the 5th. It's 1/2 times that whole thing. So each of those logs will get multiplied by 1/2. I would distribute that in there. So I'll go ahead and do that. And I will bring that 5 out front of the second log and multiply it by the 1/2, which will make 5 halves, times the log base 2 of n. So now I've expanded that log. Number 3, the log base 3 of 9 over m times n. Let's deal with the division. Division, again, means I can split it up into subtraction of two separate logs. So I've got the log base 3 of 9 minus the log base 3 of m times n. Well, the log base 3 of 9 I actually know. What power do I raise 3 to get 9? That's a 2. Log base 3 of 9 just becomes 2. Minus, I'm multiplying m and n, so this becomes the log base 3 of m plus log base 3 of n. Notice I wrote that in parentheses because that minus gets attributed to both of them. It's to that whole quantity. So it's really 2 minus log base 3 of m minus log base 3 of n when I distribute that negative into it. Okay, so that's expanding logs. But we can go backwards. We can condense logs down to a number or a single logarithm. So number 4, log base 10 of p plus 3 times the log base 10 of q. The first thing we'll do when condensing logs is take care of those numbers in front by pulling them inside as a power. So the log base 10 of p will stay, plus, and I'll bring that 3 inside as q to the third power. Log base 10 of q to the third power. That's from my third law of logarithms. So now I've got log base 10 of p plus the log base 10 of q to the third. So they've got the same base. There's no numbers in front other than 1. So I can combine these two logs that are being added into one log where I am multiplying on the inside. Log base 10 of p times q cubed. I've condensed it down to one log. Number 5. 4 times the log base 3 of x minus 1/2 times the log base 3 of y. So again, I'll take care of those numbers in front, pulling them inside as powers. Log base 3 of x to the 4th minus log base 3 of y to the 1/2. Okay? Now, I've got a log with the base of 3 minus a log with a base of 3. So subtracting two logs I can combine as one log where I am dividing on the inside. Log base 3 of x to the 4th divided by y to the 1/2. I could write that y to the 1/2 as the square root of y, but I am satisfied with it the way it is. Number 6. 1 minus 3 times the log base 5 of x. So I will bring that 3 inside as a power of 1 minus log base 5 of x cubed. Now the 1, I could write it as a log. What log works out to be a 1? Well, I'm going to choose a base of 5 because I've got a 5 as my base of the second log there. I'll choose log base 5. And what number do I need inside of the log that will evaluate the log to 1? It would be a 5. Log base 5 of 5 is 1. So log base 5 of 5 minus log base 5 of x cubed. And now I've got two logs that are subtracted. So how do I evaluate that? Or how do I condense that? I combine it into one log where I'm dividing. 5 divided by x cubed. Log base 5 of 5 over x cubed. If the log base 10 of 2 is approximately 0.30, or rounded to 2 decimal places, is actually an irrational number that will keep going on in its decimal expansion, but that's truncated and rounded to 0.30. And the log base 10 of 3 is approximately 0.48, so again we've rounded it. Let's estimate to 2 decimal places these two logs. The log base 10 of 18 and the log base 10 of 1 over the cube root of 2. Our goal here is to be able to write the 18 as just 2's and 3's. So 18, remember, is 2 times 9. So this is log base 10 of 2 times 9. 9 is 3 squared. What's the log base 10 of 2 times 3 squared? Now I've written it as 2's and 3's. Now let's expand this out. This would be the log base 10 of 2 plus the log base 10 of 3 squared, but I can bring that power of 2 out front. 2 times the log base 10 of 3. Well, I know that the log base 10 of 2 is approximately 0.3. So I will estimate this as 0.30 plus 2 times the log base 10 of 3 is approximately 0.48. Okay, so 2 times 0.48 plus 0.3 gives me about 1.26. So I'm estimating log base 10 of 18 as 1.26. Number 8. the log base 10 of 1 over the cube root of 2. So I'm dividing inside. That allows me to split it up into two logs where I'm subtracting. Log base 10 of 1 minus log base 10 of the cube root of 2. Well, what is the log base 10 of 1? Log base anything of 1 is always 0. And then the log base 10 of the cube root of 2, well, the cube root is 1/3 power, so this is really 1/3 of the log base 10 of 2. And I know the log base 10 of 2 is approximately 0.3, so this is really 0 minus, or negative 1/3 times 0.30. And 0.3 times negative 1/3 gives me negative 0.1. Number 9, let's solve this equation. Log base 3 of x plus log base 3 of x minus 6 equals 3. Well, let's combine those two logs on the left-hand side. So we'll make it log base 3 of x times x minus 6 equals 3. Alright, I've got a single log equal to a number. So I can convert this into its exponential form. Remember how to do that? Yeah, you do. You take the base of the log, the 3, you raise it to the number on the other side, the 3. That equals what we're taking the log of, x times x minus 6. Okay, so 3 to the third is 27. X times x minus 6 is x squared minus 6x. So this is really x squared minus 6x minus 27 equals 0. Hey, that's a quadratic expression. I can know how to solve that. I can try to factor it. If factoring doesn't work, or I don't want to factor, I can use the quadratic formula. Well, would factoring work here? Certainly it would. All I need is x plus 3 and x minus 9. 3 times negative 9 is negative 27. 3 plus negative 9 is negative 6. So that means x equals negative 3 or x equals 9. Well, if x were negative 3, I'd be taking the log base 3 of negative 3. And I know that I cannot take the log of a negative number. So x cannot be negative 3, since log base 3 of negative 3 is undefined. So what about 9? Does 9 work? Let's check. Log base 3 of 9 plus the log base 3 of 9 minus 6. Does that equal 3? So log base 3 of 9 is 2. 9 minus 6 is 3, and the log base 3 of 3 is 1, and 2 plus 1 is 3. So 9 works. So my solution is 9. So always check your answers. Number 10, 1/2 times the log base a of x plus 2 plus 1/2 times the log base a of x minus 2 equals 2/3 times the log base a of 27. Whew, that's a lot, Mr. Shaver. You really expect me to do that? Yes, I do. So let's take those numbers in front. Let's bring them inside of the logs as powers. Log base a of x plus 2 to the 1/2 plus log base a of x minus 2 to the 1/2 equals log base a of 27 to the 2/3. Okay? So on the left-hand side, I now can combine those into one log base a of x plus 2 to the 1/2 times x minus 2 to the 1/2. On the right-hand side, what is 27 to the 2/3 power? Well, that's the cube root of 27 and then square. The cube root of 27 is 3. 3 squared is 9. So this is really the log base a of 9. Cool. So now I've got a log of something equals a log of something. That means the only way those two expressions are going to be equal is if the things I'm taking the logs of are equal. So I can really take x plus 2 to the 1/2 times x minus 2 to the 1/2 and set that equal to 9. That's an equivalent equation to the previous equation. Alright, so now I want to solve this for x. Really, I've got the square root of x plus 2 times the square root of x minus 2 equals 9. How do I get rid of those square roots? Well, I square both sides. So I will take everything to the second power. X plus 2 to the 1/2 squared just becomes x plus 2. X minus 2 to the 1/2 squared just becomes x minus 2. That equals 9 squared, which is 81. Alright, x plus 2 times x minus 2, when I FOIL that out, becomes x squared minus 4, and that equals 81. So x squared minus 85 equals 0. That means x squared equals 85, and x equals plus or minus the square root of 85. Can I simplify the square root of 85? No, I cannot. That gives me two possible answers. Do both of them work? Well, if it was negative square root of 85, since that's definitely bigger than 2, I'd have a negative number inside of that first log. That's a problem. Can't have that. So I will just have the positive square root of 85 as my solution. And here are your immediate practice problems. Number 1, expand the log base 10 of a squared b. Number 2, condense 4 times the log base 10 of p minus 2 times the log base 10 of q. Number 3, solve log base 7 of x plus 1 plus the log base 7 of x minus 5 equals 1. And that is the end of section 10.5.